So the problem that I had was from chapter 3, section 8, problem number 13, and it asks you to approximate the zeros of the function and use Newton's method until two successive approximations differ by less than 0.001. And then after, compare the results to the graph to see how close you get. And the function they gave you for this problem is f of x equals x plus sine of x plus 1. The first thing you do is just find the derivative of that, because according to Newton's method, which is what you're using, you're eventually going to have to do x to the n minus f of x over f prime of x. So just find f prime of x right now, which is 1 plus cosine of x plus 1. And after that, make the chart for Newton's method and fill in the spaces with the results from the two successive approximations. And so for the first n that you get, you can kind of guess that one, like where the zero would be. And so you end up getting plug in negative 0.5, and then you plug it into the f, the initial function, and you get negative 0.0206. Plug it into the derivative, and you get 1.8776, and then divided by each other, and you get negative 0.011, and then finally Newton's method, which is what actually determines and finds your zeros, which ends up being negative 0.4890 or 0. But they ask you to find two approximations, so you just do it again using what you got for this one as your new x to the n. And so when you do that, you fill in all the rest, and at the end you realize that there's less than 0.001 difference, and so you realize you've done it right. And when I compared it to the graph, on the graph, when I found the zero, it said that it was negative 0.489 on the graph, which is like what we got using Newton's method.